um, had it not been given, we would have tested at 5% level of significance. But the main thing is there is that in this problem is that the level of significance is given to you. Okay. So let me show you once the table and the value. Next, when we will solve the sum, then I will not show. See, we are doing the third one where p less than p naught, right? At 5% level, we would have tested it at z less or equals to minus 1.645. Now we will take minus. This is a left tail test, okay? And the left tail test, the critical region values are all in minus, all negative, okay? If it is greater than, then it is right tail test, also it is called one tail test. And if it is less than, then it is called left tailed, also it is called one tail test. You have to remember this thing, otherwise your answer will not be correct. So z, if it is less than minus 1.645, then we reject null hypothesis at 5% level. And at 1% level of significance, we will reject the null hypothesis if z, calculated z value will be less or equals to minus 2.33. So remember this thing, minus 2.33. This is our concern, okay? Because we are doing the third part and we are asked to test the hypothesis at 1% level of significance. So at 1% level of significance, the critical region is z less or equals to minus 2.33. Okay, all of you remember this, because I'll not show this table again when we calculate z statistic. Minus 2.33, okay? Alright, so here you see, it is said that the manufacturer claims that at least 90% of his items which he supplies are up to standard. Okay, and the fact says that a random sample of 200 components were taken up and then they were tested for quality. Out of 200 sample, 164 have come up to the standard. That means they are up to the quality. And from this given information, we will have to test whether the manufacturer who is claiming that at least 90% of his components are pure, are up to the specification, that we have to test. Okay, so as you know by now that null hypothesis should always be in the form of an equals to. Now we are doing test of proportion, so we are equating it with some number. Next we will do the test of means. In there you will see we will equate two different proportions or two different means. Okay, so that will happen after this problem, tomorrow maybe. Okay, so now we have the claim of the manufacturer who says that 90% of his components are up to the mark. So we will put the null hypothesis as that the proportion which conforms to the specification is 90%, that is 0.90. So write down, in solution you write down null hypothesis is that, write down null hypothesis is that, null hypothesis is that the proportion of components, null hypothesis is that the proportion of components conforming to specifications, null hypothesis is that the proportion of components conforming to specifications is 90%. Is 90%, that is 0.90. Null hypothesis is that the proportion of components conforming to specification is 90%. That is the claim of the manufacturer. Okay, so that is 0.90, which is H naught, in bracket you write P equals to 0.9 or 90. H naught is P equals to 0.9. Okay. Next line you write, the alternative hypothesis is that, the alternative hypothesis is that it is less than 90%. The alternative hypothesis is that it is less than 90%. Now, can anyone tell me, we would have taken it to be greater than 90% also, isn't it? We would have taken it to be greater than 90% also. Why we have not taken greater than and why we have taken less than? Can anyone tell me? Here, the null hypothesis is 0.90 because that is the claim of the supplier. Now, here in the alternative hypothesis, why we have not taken greater than and why we have taken less than? Can anyone tell? Can anyone tell?
Uh, yes, because in the third type it cannot be greater than.
Third type, oh, how do we know that we are following third type? Suppose this question is given only, and you from this information given you have to decide whether it is second type or third type. Third type, though, I told you that we are doing third type, that's why you know that you are doing the third type. But in the exam, suppose this question is only given, how will you know that this is the second type or the third type?
Ma'am, because it is at least
Because it is
90%.
at least 90% means, at least 90%. That means that I am saying that at least 90% will be up to the standard. Okay, you can do that, but every time this idea will not work, huh? Every time this idea will not work. This sum it is working. I take your answer, but the main thing is you have to see the actual data. See the actual data. It is your 200 out of 200 component, 164 is only up to the standard. Is it 90%? 164, is it 90% of 200?
No, ma'am.
No, it is less. So, seeing the real data, you have to understand whether it is the second type or the third type. Okay, seeing the real data, you have to understand. Now, for clearing, giving you a clearer concept, see the last sum that we did yesterday. It was that majority of the men in the city are smokers. So once we equated the null hypothesis written in equate form, and we wrote as 50%. Now we would have taken as less than also, less than 50%. Why not? Because see, out of 600, more than 50% are already smokers. It says of 50% of 600 is 300, no, but it is 325, so more than 50%. That's why we have taken more than 50% in the alternative hypothesis. Okay, so this concept should be there in your mind, and accordingly you need to take the null and the alternative hypothesis. Understood? Okay, so alternative hypothesis is that it is less than 90%, and you will write H1 in bracket. You will write P less than 0.9. Okay, now you calculate the observed value. Write down observed value. No need to write this line. The proportion of articles conforming to specific. You just write observed value. Write down observed value in the next line. Observed value is the real value which is given in your question. So it will be 164 by 200. This is the proportion which is given in your question. So you write 164 by 200. See whether the answer is correct or not. Is it 0.82? Calculate and tell me. Once you finish calculation, you should unmute and tell, okay?
Ma'am, can you move the page little bit downward?
Downward. Why?
Ma'am, I
Yep.
wanted to see that alternate hypothesis.
Downward or upward? This way.
Ma'am, previous line. Yes.
This one. Okay. 0.82. Alright, so it is correct, no? Who answered? Rina. Okay. So it is 0.82. Okay, fine. Now, you write this line. Assuming that H naught is true, yesterday I told you that this is a line which you always have to write before writing the expected value. So write this line. Assuming that H naught is true, assuming that H naught is true, comma, expected value, write down, assuming that H naught is true, comma, expected value equals to 0.9. Expected value equals to 0.9. Okay. Next, as per our formula, by now I hope all of you have memorized the formula. The formula is observed value, no, expected, no, observed value minus expected value divided by standard error of P. Now we need to calculate the standard error because this is not given anywhere. So you write, after writing expected value equals to 0.9, next line you write standard error equals to, put a big root over, and under root over in the numerator you will write PQ by N. The formula is PQ by N, capital P, capital Q. If you are writing with small p, no problem, small p, small q by N. That also you can write. But here in alternate null hypothesis, we have taken capital P. So you will write capital P, capital Q by N. Thus, the value of capital P is 0.9 and the value of capital Q is calculated as 1 minus P. Okay. If you are unable to get me, do prompt and make me stop. I'll explain again. P is 0.9 and Q is 1 minus P. Thus, Q's value will be 1 minus 0.9, that is 0.1. So, in the numerator, it will be 0.9 into 0.1. P and Q. P is 0.9 and Q is 0.1 divided by N. N is the sample size. It is 200 here. So write down 200. 0.9 into 0.1 divided by 200. So what I told you, you will first multiply the numerator, whatever values are given you multiply, that is 0.9 into 0.1 you calculate, you will get 0.09. Use your smartphone and calculate. 0.9 into 0.1, you will get some value, divide that value by 200. Again you will get some value. Then you find out the root over and tell me whether it is correct or not. 0.0212 is the correct one or not. Tell me.
Ma'am, it's correct.
Correct. Okay. Very good. All right. So let us move ahead. Now we can, now as we have the value of observed, we have the expected value. Also, we have calculated standard error. So we can calculate the value of test statistic. Next line you write the value of the test statistic is. Next line you write the value of the test statistic is z equals to, the value of the test statistic is z equals to, formula is observed minus expected. So 0.82 minus 0.9. You write this. The value of the test statistic is z equals to, in the numerator will be 0.82 minus 0.9 divided by 0.0212. Calculate and see, it will be minus 3.77. Minus 3.77. Okay. Have you got this answer? Minus 3.77. Tell me whether when you have completed, okay? Minus 3.77 you're getting or not, tell me.
Ma'am, it's okay.
Okay. So now our main task starts. Whether we will accept the null hypothesis or reject the null hypothesis, we have to decide. So in the beginning only I showed you the table. It was given that the critical region, that means the condition for rejecting the null hypothesis is at 1% level is the calculated z should be less or equals to minus 2.33, right? It I showed you only in the very beginning. So minus 3.77 is less than minus 2.33, isn't it? And you might be confused that it is 2.33 and what is 3.77, how is it less, right? If the minus sign is there, if the value is a negative one, then the more you increase the value, the less will be the amount of the number. Okay, this is the rule in mathematics. Those who have not got much good hold in mathematics, I know you might get confused that 3.77 is more than 2.33. Then how it ma'am is saying it is less? The reason is there is a minus sign. If minus sign is there, then more you increase the numerical value, the less will be the total value of the number. Okay, so because we are going on the left hand side, and then the left hand side we start with minus 1, minus 2, minus 3, like that we go towards the left. So the more you go towards the left, the less will be the value of the number. Okay, understand this, remember this fact. So when the value is minus 3.77, it means it is less than minus 2.33. So you write this line. Since the value of z, that is minus 3.77, is less than minus 2.33, write this line. Since the value of z, that is minus 3.77, is less than minus 2.33, In bracket write down critical region at 1% level is z less or equals to minus 2.33 bracket close. Critical region at 1% level is z less or equals to minus 2.33 bracket close, comma, the null hypothesis is rejected. The null hypothesis is rejected, and if it is rejected, it ensures that the test that the manufacturer's claim that 90% of his items are up to the mark is not justified, because null hypothesis was proportion should be equals to 90%. Had we been able to accept that fact, then we would have said that the manufacturer's claim is correct. But null hypothesis is rejected. That means the claim is not justified. You write this line. Are you understanding, all of you? Sheetal, tell me, are you understanding why we are rejecting null hypothesis?
Yes, ma'am.
Yes. Write this line finally, huh? Okay, if you have written this line, you can leave the class. The class is over. I have given you attendance. And those who have not yet written, you write and then leave the class. Tomorrow we'll do some test with mean.